Okay.
Hey, welcome to HTM Hackers Hangout. I'm Matt Taylor from Numenta. And if you're new to this, I've got a lot more YouTube subscribers nowadays than I used to. So I do this like once a month. It's live, unedited, uncut, so I'm going to make mistakes and stuff. Skip it if you don't like the cheap production. I don't care. But I always give an update about what's going on in the community, and it's an invitation to people in the community to discuss things with me. And sometimes I grab people from the Numenta research team to come in and have discussions. They've been really busy lately, so I didn't go and ask them to join us this time. But I'll give you all the updates from what I know. So look in the notes of this video. If you're watching on YouTube, there's a link to our forum, and we've got a topic that's got links to the stuff that I'm going to talk about. And you can get involved in conversations there if you don't want to join live here in YouTube land. So my quick rundown, I'm going to talk about, we've had a lot of news since last time we did a Hackers Hangout. We released 2 papers, and we got an article in the New York Times, like the print version of the New York Times. It came out on Monday, 2 Mondays ago, I think. So it's been almost 2 weeks. Seems like longer than that, but we got some good publicity out of that. This article, like I said, is linked on the forum. It definitely presented the company Numenta in a good light. It was a very high-level article about the new theory we're working on in object representation and the framework for intelligence using grid cells. But it missed out on one big thing that I'm very focused on, is our transparency as a company, our openness as a company, because I run the open source community, and it really gave the impression that Numenta was closed, and I really don't know why, because we're so open. We're just so open. It's like that's my job, is trying to make us. I remember when I first started working as open source community manager, Denise Cooper, who really mentored me in that role, who's really active in with O'Reilly and the open source community. She told me, your job is to make as much as possible public. And Numenta hired me to do that. That's what they pay me to do, is to pull that lever as much as possible and make sure that we can release as much as stuff that we do as possible. And I work to do that. So if you got that impression, it's not true. Go look at our GitHub, all our code, all our papers and stuff. And like this, what I'm doing right now, I'm going to talk to you about stuff I talked to Jeff about yesterday. So it's not like we're hiding anything at all. We think this is really important technology. Hey, Mark Brown, nice to see you. Just saw your post. Easily distracted, ADHD, sorry. What was I even talking about? Anyway, the article was great. I wish it didn't paint us as a closed company, because we're not. That's it. Anyway, so now we've got a bunch of papers. And now I also made a list of the papers and sort of what we nickname them. So the latest 2 papers we call the frameworks paper, and that's the one the New York Times article referenced. And we call it columns plus, because we did another paper we called the columns paper, and that introduced the idea of object representation in each cortical column, but not like how the location was represented, just that a location is necessary. Columns plus does like computations and simulations using a location based upon grid codes, sparse codes that grid cell modules represent. Anyhow, so those are the 2 latest papers. I'm working on 2 more HTM schools. One is going to finish up sort of the frameworks paper, because the first one, the one I did just recently, stopped short at really explaining the whole 1,000 brains theory. The idea, the repercussions of the idea that every cortical column in your neocortex is attempting to represent an object at the same time. So I'm trying to work through that right now and come up with some good metaphors, good visualizations, good ways to explain how this conflicts with classical hierarchy, and also contributes to our understanding of how we think object representation is working through a hierarchy. I mean, there's still a hierarchy, but it's not a simple, I think, hierarchy. It's a really messy hierarchy. And the idea that that each column can represent an object helps at least wave away that complexity of the messy hierarchy a bit. That's my take on it anyway. I was just talking to Jeff about this yesterday, because I keep thinking about hierarchy all the time. And by the way, I'm always way behind the research team. I'm not on the research team. I'm like the guy that tries to make this understandable for everyone. So they're always way ahead of me. So whatever I'm talking about, they've already thought about like eons ago, and I'm just catching up with, okay? So I'm thinking a lot about hierarchy right now and trying to understand how I can present it to people. And anyway, I was talking to Jeff yesterday about it because I got this impression, and I've read some forum posts about this too, that hierarchy is emergent. And I felt like, oh, that makes sense. Hierarchy, the structures, the regions, like how the hierarchy, the architecture of a hierarchy constructs itself. Maybe that's emergent over time. Maybe that's dependent on the sensory input, and maybe it's learned. And so I pitched that to Jeff yesterday, and he said, no, he doesn't think it's emergent over time. He thinks, but yes, it's true that the hierarchy is different in the visual cortex than it is in the somatic cortex or the auditory cortex. Those are different hierarchies, and they're structured differently, and the input's vastly different. But he says that how those regions are connected together and how they're connected is something that evolved along with the sensors. It's not like it's not a blank slate like he thinks the structure for those hierarchical structures between regions. Along like the sensors. It's not. Sorry, go ahead. What was that, Jacob?
Yes.
He thinks the structure for. How are you doing? Oh, I just got some audio from you. Did you have a comment? Sorry, go ahead. What was that, Jacob?
Yes.
I think it's just an echo. Okay. I'm going to mute you. All right, we muted Jacob. That's live. It's live. That's proof. Anyway, I am just rambling now. So really good read, if you're interested in this stuff, is Mount Castle's The Columnar Organization of the Neocortex. It's a great paper. I think that summarizes a lot of different research like that puts together the argument of columnar organization. And it goes into work of Hubel and Wiesel, which is really old stuff, but it's applicable, and they're talking about the visual cortex. Jeff also told me take that with a grain of salt. A lot of that stuff hasn't aged well, but I won't go into the details of it. But the interesting idea is that there's sort of these slabs, and that they are responding to different orientations. That's an interesting idea. That's something that needs to be explained, I think. Okay, last thing that I want to talk about, Lewis is an engineer that works at Numenta here. He's not online right now, but I thank Lewis all the time. He does a lot of great work for us as a community that you don't see behind the scenes. He's working on some of our NUPIC pipelines that the contribution validation broke. If you're a programmer, you sort of know. You create a pull request and we validate it, make sure that it's good to merge. One of them broke that checks to see if you've signed the CLA. Lewis is working on a better system for that. We're trying to simplify our pipelines now that we don't have a whole bunch of products being built on top of NUPIC, and sort of simplify it, streamline it, so that as we go in the future, if we do want to build something back up, we won't have a big mess. You know, we'll have something clean and streamlined. So that's happening, Paul. That you might notice that. I know you have a PR or two in NUPIC core right now. I still want to come back and address those. I think we have some Windows builds problems, but once that we may move to. I have no idea what the state of that is, but those two PRs, there is some Windows problem, right? We can talk about that offline, but that's where we're at. Okay, I'm done. That's my update. I do want to point out, if you're not a member of the forum, go to the forum. There's an interesting discussion. I learned a long time ago not to talk about free will on the internet, but there's a discussion about free will on the forums. I'm not interested in getting involved in that, but you may if you wish. There's some other interesting ones like why do we need sleep? I think that's a really interesting idea of the brain sleeping and why it's necessary. The forums are very active. There's a lot of new people coming in with some interesting ideas. Come on in and have a look. If you're watching on YouTube right now, it's in the show notes. Just click the link. You're in the forum. Boom. Anyway, that's all from me. So let's take comments from the community. If anybody has one, pipe up and I'll address you. I always have to wait a long time.
This is Jacob.
Hey, Jacob.
Hey, we've been actually working on some stuff. I can't share it yet, but hopefully we can get it released soon. Kind of an applications perspective of HTM theory. And yeah, I can't go into it right now, but I need to get into the company. But I think you'll find some pretty interesting because we took a little bit of a different approach. So
I think I'm getting a bit of feedback from something. I think the microphone, but you're building something on top of HTM. You can't release the details yet, but something soon. But is it working? And
yes, it really works.
Cool. Is it an anomaly detection application?
Yes, sort of. Yeah. But we wanted to be able to do more complex architectures, which we found very difficult to do with NewPick.
Right.
So we had to do our own thing. But other than that, I look forward to sharing some details and even some analysis later.
Well, I look forward to that. Thanks for joining.
No problem.
By the way, Jacob, who are you on the forum if you have a forum account?
Jacob Everest.
All right, nice. All right. Mark Brown is on chat. Wait, I guess you guys can read. Well, the people watching can't read it. He's talking about cerebellum sequence generation, mode programs in the forebrain. Wow, what exactly does HTM do? Mark, if you want to talk about stuff, you should join and talk about it. Oh, I think he's just telling us about. Oh, he's summarizing the different topics, I think. What should come first, right, on the forum? Or is there an adversarial model? Okay, so now, at this point now I'm just reading chat, so I should probably close off because there's nothing going on.
Hey,
so anybody else?
Hey, Matt?
Yeah.
Hey, sorry. Just real quick. First of all, it's awesome to hear just everything that you're doing, and definitely weren't rambling. And neither will I. So I quickly I had a quick practical question and a quick, I guess, reporting of something, of a finding that I thought you might find interesting, just very briefly. So I'll start with the question, maybe, because it's the most direct thing. Essentially, I wondered if, so I'm working with a small amount of data, but the application is still working well because I'm doing pre-processing that sort of smoothens it out, but it reduces the amount of data such that obviously I'm still getting anomaly scores, but the anomaly likelihood just doesn't kick in because the anomaly likelihood goes at 0.5 for a long time before it actually kicks into something else, depending on there are certain basic, whatever, hyperparameters to that. So I essentially wondered, is there any like rule of thumb? I don't know if there would be a rule of thumb or just a way that you would think about saying like, okay, well, if instead of having like literally like I'm doing a thing where I'm building models, saving them and running testing data through them. So I'm like saving and then calling them back in. And the testing data is only like, it's like I'm trying to identify people by ranking similarity. I have like 40 people and there's only a couple of hundred of data points, often like a couple hundred to several hundred testing points and maybe like 1,000 training points. So the anomaly likelihood doesn't kick in. So I figured there would be some parameters that I could change to try to make it kick in. I'm just using raw anomaly scores now, which is actually working pretty well. But I heard you saying, I highly recommend the anomaly likelihood. Like I just heard you saying that in my mind. So I was like, I should try to figure out a way to at least try this because it's just 0.5.
Yeah. Is this a problem because you're serializing models and then unserializing them, or there's just not enough data yet to do a proper likelihood window?
As to the extent that I understand what I'm doing, which I think I do, it's about not having enough data yet. Because I have noticed that when I've done other things where I did have enough data, it would flatline at 0.5 for a long time in the beginning and then it would drop, you know what I mean? And then only spike up for a real anomaly, which I know I want to do. And also because I just want to be able to control that because I'm going to do another experiment too, where I think I'll really want to have the anomaly likelihood especially. And I may have more data, but it may still not be enough. So I just want to be able to essentially know how to control that. So I know maybe I can make a post for this in the forum and it'd be easier to address it that way, but something I'm dealing with. Sorry?
I've had this issue. Basically, I went into the code, the Python anomaly likelihood code, and just persisted the window between runs. So I didn't reset it whenever I reloaded the model.
Okay.
That's in between serializing and deserializing.
Correct.
Right? But there's also some core parameters for anomaly likelihood, like the window size, that you might benefit from making smaller.
I was thinking something like that. Yeah, I know there must be.
What Jacob's saying is right too. If you're serializing any of these models and unserialize them, you lose your anomaly window, your anomaly likelihood window. So you should keep that around. Don't or figure out a way to serialize it, and because it's just an object. I don't think
the thing is I think I want to lose because I have a traditional sort of training and testing setup. So in other words, like just really quick to explain, like, so Matt, so you play a game with a joystick, right? It's this basic manual control task. And I have that. It's a simple task. You do it over and over again. It generates sequences that identify you. It works pretty well, right? And so basically, what I do is I train a model from you, but I also train a model from 40 other people. And then I take a couple of your runs as a MAT sample, like a test, a MAT validation set, basically. Run it through all the models. Get everybody's what I'm now using, just very crudely, is just mean anomaly score, and then I'm ranking all the models. And what happens is the MAT model will rank in first place, maybe 55, 60% of the time and be pretty high in the rankings most of the time, just doing that, just doing that basic simple anomaly score. It works a lot better because my sampling rate was too high. So I downsampled the data a lot using like a pre-processing aggregation, but basically, so it made it so that a small amount of data made the performance a lot better. So in this case, I want to cut off I want to start a new anomaly window with each small test data sets. Like I have 200 test data points. I want to get some kind of metric to say how well did this model do predicting on this particular test set, right?
So you've got these are sort of batches, right? Batches of controls.
Effectively, yeah.
So you want your window to be small enough that you can identify within that batch who's playing.
Yes. I want the anomaly likelihood to stop being 0.5 soon, basically. So I know that must be. I know dig through the documentation, but you're thinking like in that anomaly likelihood.py file, there would be some.
Yeah, that's like a typical Python class, and I'm sure if it's not a parameter when you construct it to specify a window size, I'm sure you could easily figure out where it's set. It should be a parameter. I imagine it's a parameter.
Yeah, I think because isn't it sort of like it's essentially doing like a running z-score on the anomalies, basically? It's like they maintain a distribution that they make into normal, and they say, oh, if this is at one of the edges of the distribution, it's like, because it's cool because obviously it means the anomaly score is changing. So if it goes from unpredictable to predictable, that's also an anomaly, right? Whereas like with anomaly score, everything unpredictable is an anomaly. So that's what I'm using now. So I'm thinking like it could maybe work better. And I know obviously having more data makes a big difference, but like with the raw anomaly score, the results improved a lot because it was too noisy. I was losing the forest for the trees. So anyway, sorry to take up all that time, but just wanted to.
I have a quick question on that. Whenever you are doing your training for you said 40 models or something. I assume you're categorizing those. You're labeling them. It's not learning it itself, right?
Right. Or I have I have them numbered. So like model 0, model 1, model 2.
Approach this is from an object recognition perspective. So you create an SDR for each of those 40 things, and then
one SDR.
Yeah, one SDR.
Right, I have like a saved temporal memory model. So you mean like boil that down into an SDR?
Yeah, and then provide like distal connections to the sequences, right? And then so just like whenever you're recognizing a new object, when your first input comes in, it might predict a lot of stuff, but it's eventually going to narrow down just like an object would narrow down.
Okay.
That would be considerably more work, but he's right. That would be an interesting way to go about it.
Yeah, sorry. I'm not sure how I would do that.
That is so
from a theoretical perspective.
Theoretically, like having a more final control or fine control with like algorithm API or something.
Yeah, that's certainly how we should be doing this. Like in the future, this is how we would be doing it, is more the way Paul describes it, is creating representations of things that's not just temporal. What we're doing with sequence memory and doing classification basically by anomaly detection, as we're trying to shoehorn spatial sort of classification over time into just a temporal classifying system or a temporal prediction memory system.
Like it feels in its what has been called temporal pooling, or at least to me, like having a more stabilized layer that says not, oh, A is going to be B is going to be C, but like, oh, this is the alphabet, and I'll wait for the alphabet to be done. That recognizes that you're within a larger sequence. Like, and I know, Paul, you've done so much work on that, and everybody there. I would love to incorporate that into
Yeah,
it too. But
I'm getting pretty close to having a self-organizing temporal. Eventually, one that you don't want to have to label it ahead of time, right? But in your case,
Right.
you already are labeling the 40, so you can get away with just create a random SDR and then connect it up to your sequences as they're learned, right? The hard part of which is what I'm working on is getting it to come up with those 40 by itself.
Coming up with those 40 distinct SDRs.
Exactly.
Because, okay, so by that measure, it's like what I now have is like a training file and a test set, and it takes a while because I have to run every test set through every training file. So it takes a little while. But if I just had an SDR, it's like, oh, here's the representation of Paul playing the game, and here's the another representation of Paul's test set that was held aside, right? So basically, you know, that other 30% or whatever it is, and that creates another SDR, and then I could just do basic SDR, essentially overlap score, which I know is super fast. So it's basically a way of taking, yeah, it's a temporal pooling approach. Well, anyway, I'll go back and read some of your other old stuff on, I know you have so much on temporal pooling, and yeah, I'd love to get into this more. I don't want to drag everybody into it, obviously.
The unsupervised bit, that's what Paul's talking about, you know, identifying the objects based upon, see, it gets really deep really fast when you start thinking about this, because we always have to introduce motion. At least I always have to think about motion when I think about identifying objects, because when you move from one object to another, there's a transition. There's an obvious transition. There's a state transition in your brain. You're putting tension from one object to another.
Right.
And we don't know what's exactly how that's going on. But we're trying to model or understand how we model the things that attention plays through, that attention directs. You know, we want to model those things.
Right.
So a lot of these questions, we brush them off because we don't know how it works. And temporal pooling is such a catch-all term at this point. It used to mean something like specifically for us, and even early on in NewPick. Now,
it was like temporal memory used to be called temporal pooling.
Yeah,
right?
Let's just
and if you watch some of the really original videos, some of the original videos that Jeff did, you know, when the theory was still young, he distinguished between the temporal memory or sequence memory and the pooling part. So it had an original meaning, but they combined them into one algorithm originally and then broke it out. So my definition is kind of similar to that original meaning, but obviously I've deviated quite a bit from the way it was, you know, originally theorized. So at some point, whenever I get it actually working, then it'll be a matter of talking it out and, you know, getting to a biologically plausible implementation.
When you do get it working, call it something more specific.
Yeah, we can also talk about what we call it once it's done too.
Because even in the machine learning community, they are talking about temporal pooling now. And when they say it, they mean it in a very generic way, you know, just like pooling over anything else you might pool. It's just a temporal pool of things. It could be a bag of objects over time. It just could be a moving window, you know, that could be very simple. So what the brain's doing is a lot more complicated and detailed.
I just think of it as something that is watching a temporal pooling, like a normal, not temporal, excuse me, a normal TM region, right? That's, you know, it's being sparse if it's predictive, and it's bursting if there's a lot of unpredicted stuff. That's like watching that and then saying and recognizing just larger temporal structures, essentially.
Yeah, exactly.
You know, because the temporal memory is like, what's going to happen next? What's going to happen next? What's going to happen next? And then this other thing goes, oh, this is that sequence when it went, you know, ABC, ABC. You know what I mean? Like it's really recognize that. Yeah, obviously.
Yeah, it's the label of the thing. You know.
Actually, and the motion aspect too. You always have to think about the motion aspect, because you're not thinking about just what's going to happen next to me. It's what's going to happen next because I did this. What's going to happen next because I moved here, because I'm here now. And I feel like whatever motor command is being emitted by your brain, you know, the columns, the cortical columns that are processing just this patch of skin, it's important to know a lot more than just where this patch of skin is moving, potentially. It's got to know a lot of information. I mean, you have to put together a ton of joint information to figure out where that patch is going to be. So it's a big motor signal, you know, describing the state of you as an interface to reality. in a lot of different ways.
I think a simpler problem for figuring out the basic function of stabilizing the quickly changing temporal memory into something that's more stable over time is to look at from the perspective of music or a song or something, right? Something that you're not producing, but you're hearing, but yeah, you can still predict what's coming next. I think that's a little bit easier.
Of that. I'm like, oh, this is the chorus, this is the bridge, this is verse 1, this is verse 2. Like totally, I always think of that at this example, like, or when I'm listening to a song and I'm like, oh, this is the chorus. I'm like, I'm doing temporal pooling. Like that's what I think of in that moment. I said to point that out. That's a great example.
Yeah, but I think you have to start there. But obviously, it gets way more complicated when you start talking about now I'm actually impacting or affecting what it is that I'm going to sense. So
right, yeah, that's a whole nother.
It's going to evolve into something quite a bit different, I'm sure.
Yeah, no, everything that I'm trying to do applied wise is totally from a passive perspective in that way. It's like his ideas, like general ideas, like human control monitoring, and then like, you know, doing identification or doing like, oh, are they getting distracted? Is the task that they're doing getting more complicated? You know what I'm saying? Like, are things funny with how they're acting right now, and like assessing workload and stuff like that. So I thought that like the temporal memory region, basically in keeping track of like the anomaly scores and how many, you know, essentially how many neurons you're using up and how many segments you're using up to measure sort of like complexity and entropy, could be like that on its own could be a useful way to use that structure that, as far as I know, it hasn't been used that way, but I know I have a lot of like left to do. So, okay, I'm sorry to keep talking to you guys. Thanks so much for entertaining my questions. Yeah, everybody's really smart and awesome, and this is great. So thank you.
That's why we do this. So, you guys, we haven't had a hackathon or any like group meeting in a long time, so it's nice. And there's a lot of people out there that are watching that can't join in, and at least they get to see sort of the discussions we're having and know what we're talking about on the forums. Mark, get a microphone. You can join in next time. He's in chat, like chatting all this stuff.
I'd love to hear what he has to say
on the forums. But all right, well, let's wrap it up. Unless anybody has any closing comments. At all.
Yeah, just want to say thanks, and we're actually getting ready to submit this like paper on this for publication, where it's like using HTM for this. So it's like introducing HTM to this like area. So I kind of feel like, almost in a sense, like I would want to make sure I don't say anything wrong. So I'd almost like want your guys' approval, but I didn't want to like bother you with that. So I thought maybe I'll just like post a preprint or something if it gets accepted. Like, I don't know. Is that cool? Like, I wanted to.
Yeah, that's totally.
Obviously, I mentioned you guys and New Pick. We're using New Pick.
We're totally open, so we're not.
Yeah, I've seen other people just like, there's like a Chinese university where they do a really good introducing HTM. You know what I mean? It's similar to papers that you've done, and Lee, I think, uses some of the same figures. And I'm like, all right, this is a cool way to explain it too. But it's basically the same thing that they.
No, I love finding stuff like that. It's great.
Now, what is the appropriate venues for this type of research, for like computational models and so forth?
So a bunch of our researchers right now are at SFN, which is something, Society for Neuroscience. So that's a conference that they do every year. And then what's the other one? Cosine. I mean, they're not all focused on computational neuroscientists. There's a lot of standard neuroscientists. I mean, you get a good mix, you know.
I'm more applied, so I try to stay away from the neuroscience, or I try to divorce it from the neuroscience.
Well, I mean, the direction's going that way. So I would say whatever they're calling NIPS now,
NIPS.
You know, next year, and NPS or something like that.
Are they receptive to HTM yet?
Not quite. I mean, but the tides are turning. I mean, the last time we had big news and we had like a paper come out, and the machine learning community was hostile. I felt attacked. This time, there's been little to none of that. So that's a really good sign, I think. And there's a lot more people on our forums that are trying to apply deep learning techniques, RNN, and they're coming from that background to us, which is a good sign.
Yeah, I think one of the challenges is it's really hard to understand what's going on. But I think HTM has a advantage in that you can actually understand what's going on in the black box, as opposed to, you know, artificial neural networks. It's really difficult to figure out what's going on.
Yeah,
I made that point to a recruiter yesterday, literally. who didn't know that much, but like I was trying to like be like, oh, I know about this stuff, and then I like did a slight distinguishing to HTM. She was like, yeah, they're asking you about like LSTM, and I'm like, yeah, that's good, and like I understand why they use that, and there's some stuff you can use that you can't use HTM for yet, but like it is a black box, like it's totally, I don't know, yeah, it's awesome for a lot of things. Sorry to interrupt.
And to say, we had a conversation a bit about this. So we definitely want to understand it. We want to understand how it works. I mean, I don't think you can truly build something great until you understand what you're building. But the intelligent systems that we build may not be something we can just tap into and see, oh, these neurons are on, that means it's thinking about this, you know.
Right.
They're going to have their own sort of internal, I'm going back to the Max Tegmark's definition of reality, internal representation of reality that's modeling the external reality, the same way that we have internal representation of reality that's modeling external reality. And what we have to do is create a consensus between intelligent systems and communicate between them. That's my position, not Numenta's position. That's like Matt's position on this. I'm just philosophizing. I think we're going to have to communicate with these systems that we build, as well as, but we can do it really efficiently. I mean, they're computers. We have computers too, right? So we can create protocols and super fast communication, you know.
You have to establish a language, basically.
Yeah. Communication. I mean, that's what, just like TCP/IP is establishing in some ways a language. As long as they understand the protocol, we understand the protocol, we can update.
Well, the protocol is different for every HTM. So
exactly, well, that's the thing. But I think, especially in robotics, Mark was saying something in chat about this. Robotics, there are huge applications for HTM and robotics, but we have to start thinking about robots as a complete system, you know, like a sensory array. And we've got to like construct a way for it to move through space and feel at the same time and like understand itself. Like part of what you do as you're building an intelligence is model how you and reality are different, like the boundaries between you and reality and what happens when you do this and reality does that. And
that's where people, I think like common people will start calling it artificial intelligence, you know, because like they'll sort of ask me like, oh, so you're working on artificial intelligence. And I'm like, yeah, like I am. Like to me, this stuff is the most close, definitely the only thing that I would actually consider to be like really fully like very intelligent system. Yeah, it's like to be able to understand your environment. So is that aspect of it, of like the sensory motor modeling of like, oh, I'm in this kind of place, and if I go over there, I'm going to crash and blah, 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 like that kind of thing. Is that where you see like that type of part of it is where you see HTM being really important in robotics? Because I agree that HTM is going to be important in robotics, but I can't say with the specificity exactly why. I just kind of like think so, you know. So if you have like more specific intuitions or anybody does, like that's like super interesting to me. So
I think the sensory motor learning is, you know, I've read it and I've kind of seen the implications of it, and it seems to me that it's kind of the substrate for a lot of higher level thinking. I mean, the sensory motor learning by itself is pretty interesting, but I think how it can be leveraged into lots of other conceptual thinking problems, it starts to make sense, like how the brain does certain things that, you know, computationally very difficult. That's my opinion. I don't have any evidence yet.
Makes intuitive sense to me.
So I think it's the same way. When you think about it, especially when it talks about object representation and grid cells, I really love how grid cells come together with the idea that we have on how objects are represented. You know, because they're oh geez, what's the? I've lost my train of thought here. So you get too deep in philosophy and you get lost. Happens to me.
Grid cells representing objects and the brain's efficiency in reusing.
Okay. I got it. Okay, let's think about this. Think about throwing a ball. Okay, there's a big motion involved in that. And
I used to be a baseball pitcher. Hell yeah.
But that's the same thing as an object in some ways. It's the definition of something. It just like there's a definition of a cup. I don't really keep a representation of this cup in my head. It's just a cup that happens to be in my office. I don't know how many squares there are. I just know it's a cup. You know, I don't have a special representation for this cup. There's 4 of them in here somewhere. I know that. But I know it's a cup, and I know exactly how cups work because I have this fuzzy representation of cup. Like I have an idea of cup that I can easily mutate and apply in different ways. And I think that you can match that. So I like to think about that idea of a cup as an attractor. I don't know if this, again, this is not Numenta talking. This is me talking out my.
That totally makes sense. And like, I see that in like a certain space. It's like how you can see, you could see like a big, whatever, like a big canyon from a certain angle or something else that's totally not a cup and be like, oh, it looks like a big cup.
Yeah, yeah.
You know,
because
it's got some of that same basic.
On an attractor that wasn't the one. You're trying to apply your sensory features that you're sensing to attract the things you've defined, sort of that snap to, in a way, something that makes sense. And I think that you can think about concepts that way, in the same way. In the same way as like when you fill, I mean, the metaphor of filling something up, when you're full of something, it feels like you're full, right? Like a cup is full. I don't know. Now it's getting crazy.
It's a concept. Well, it's like you have a tangible grasp, because we can say like, oh, I was full of doubt or something like that. Something that has no physical, real embodiment to it. But we understand the idea of being full of something. It's different when a person is full of something than when like, oh, the wheelbarrow was full of dirt. Like you wouldn't say a wheelbarrow was full of doubt. You know what I mean? Like that all of a sudden makes no sense.
But we're applying a metaphor from physical space to an emotional space or a mental state. Right. And the metaphor feels like it does in space. So I feel like the concept of applying space inside our own brains as we think is very natural.
And it makes sense because like you can do, it's like, because that's what the cortex does. I mean, or just like intelligent natural system, like make a really generalizable mechanism that can just be applied like across the board. So it's really simple and really complex. Obviously it must be really complex in a lot of ways, but it's as simple as it possibly can be, while having the crazy capacity that it does have, you know. And it seems like I'll just say this real quick, like the things that make like maybe like convolutional neural networks work well on certain things, or things that there's a lot of papers about that get big attention because they have like certain application spaces, like recognizing images and doing certain things like that. Like it's because they're starting to get at concepts that are a little more neuro-like, but that HTM is like actually doing completely. It's like convolution works a little bit like spatial pooling and does a bunch of whole other crap, you know, but it can process the pixel images. It can do that data type. Whereas like, I know there's some work, but like with HTM structure specifically, it hasn't been done that much with images. So people think, oh, convolution is the best for images. It's like, well, it's good because it's doing something that HTM is doing way more of.
Well,
and without, you know, shit.
Next week, I'm going to interview Blake Richards, who's a neuroscientist, but he's really into deep learning, and the deep learning community really respects this perspective. And he's talked a lot about credit assignment through apical dendritic computation. And he's written a paper about this. And I'm going to talk to him and I'm going to ask him those types of questions, you know, because that's not far from what we're talking about HTM is, which is you know, prediction based upon distal dendritic computations.
And it seems like the basic, real quick, sorry, like the basic like outer limit of, in terms of like trying to be like a practitioner, because I see this as like, wow, there are so many things that HTM could bring so much to, that they're just not done that sophisticated of a way, like human control modeling. I was shocked at how simple it is. Like I went to my professor and he was telling me about how simple it is. Like he's a researcher in this stuff, you know? And so I was talking about HTM. He's like, whoa, what is that? And we got to try that because there is nothing like that that's been done over here.
Well, I'm going to ask Blake, because he knows deep learning. How do you make a deep learning system? How do you make a convolutional neural network or with credit assignment and with apical computations? Like, how do you redo the neuron model to do that? Because I think he's thought about it. So that's
and just that base, and like just like the very last thing, it's like, where are we?
Yeah, you said that like 4 times. So
I said that this I promise will be it, because this is and it comes full circle. And I remember Paul was talking about something like this was it last month or 2 months ago or something, where it's like you could use deep learning to essentially do dimensionality reduction of some kind to feed into HTM, because I feel like the limit of HTM right now is literally the data types that it can know how to process. You know, like deep learning systems are built for like, you know, all those weird pixel values and stuff like that. They're very specifically for visual data, whereas HTM, like, it has its own native structure and you have to be able to create encodings, and then that goes into spatial pooling.
Auto encoding, that'll make your representation.
Auto encoding.
Yeah, the deep learning auto encoding, just look it up. It makes it to a smaller dimensional representation.
Okay, okay. I'll check that out because I heard when that guy Siraj did the video on Numenta, which I watched recently. That guy Siraj, he's like, "Hey, it's Siraj, machine learning," and he does
Yeah,
a video on Numenta, and he mentions he's like, "It's kind of like an autoencoder," and da 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 da. And yeah, I gotta check that out because I was like, "There's no way you could like just summarize it like that." But okay, I'll look into that.
I'm doing on all kinds of data right now, all kinds of data except imagery. I let somebody else do the image processing, and I take the results.
Good idea.
There you go. Awesome. Cool. Fascinating. Thank you, guys. Awesome time.
Well, I think deep learning and HTM, it's probable they'll merge at some point in the future. I mean, they've got all this structure for running deep learning. If we can figure out a way to change the neuron model that in a way that allows different types of connectivity, who knows?
People are tired of backprop too. They're like frustrated with it, or they realize this is too expensive. It's unrealistic. You know what I mean? Like I feel like that's where the awesome, sparse, like Hebbian like learning of HTM. Like when I knew about backprop and I saw HTM learning, and I was like, that makes way more sense and is way more powerful and is way more efficient and way more everything good. And now I see anything with backprop and I'm like, oh my God. It's like seeing like it still uses a steam engine or something. Like,
well, read Blake Richards' paper
Blake Richards.
Assignment with apical dendrites.
Yes, very interesting.
It's sort of theoretical, which is interesting because you don't read a lot of theoretical neuroscience papers. But he takes evidence found in other, and this is a big thing. You know, there's so much neuroscience data, and people are sharing it a lot now with the open science movement. So you can make a career, have a neuroscience lab, and not actually do experiments. You can get all the data from other people's, and then say, what can I understand about the brain with this data? You know, what questions can I answer? But anyway, we're running way long here, so we
sorry
should
guys,
probably
thank you.
wrap it up. No, that's okay. This is great. You know, go back and listen to some of the other Hackers Hangouts. There's a few of them where I'm just alone. And it's
oh my goodness.
I'm joking. Wow. I would gladly do a live cast to an audience of one.
yeah.
Okay, guys, I'll let you all go unless Thanks anybody has anything else besides Sam.
It's done.
Okay. See you guys on the forum. Thank you. And like the video, by the way, it helps my stats.
All right.